Hello everybody and welcome to my final project for Robot 173 Introduction to Microcontrollers at the University of Advancing Technology. I love this school. Okay, so for my final I had to make a robot car and I had to use a distance sensor to sense distance to send signals to the robot that will trigger different actions. For example, if there's really nothing in the way, drive forward. If we sense something in the way, then we're going to stop, go in reverse for a little bit, turn out of the way, and then resume going forward. If by chance we get into a situation where we're going to hit something, we apply emergency stop and it will stay stopped until we either remove the object out of the way or we move the car to a safer location, in which turn it will start up again and move forward. It will constantly move forward until either turned off or it senses something within a certain distance. Right now I have it at like 14 centimeters or so. And then it will carry on. It will perform its maneuvers and carry on. So let's look at the code. I have constant integers for the distance sensor. The trigger and the echo are set to pins 9 and 10. Straighten this out a little bit. And those are pulse width modulation. So we can sense the distances. I have a volatile long counter, and that is for the encoder. I have an encoder on here because we want to measure the uh, the time between the cycles of. So basically, in layman's terms, what we're going to do is we're going to use the encoder to tell the remote control car, the robot, to back up a certain distance and then turn for a certain distance. And it's very sensitive. It works great. I have integers that calculate the distance of the object. We take the duration and the distance, and then we apply a mathematical formula to that, and we get centimeters. Okay. Global variables here, constant is your ENA, ENB. Those are your enable pins on the H bridge. Left, left B, right A, right B. Those are your basically your outputs from the H bridge to the inputs to the motor. Basically, it's going to tell the motor if we're going to go forward, left, right, stop, or reverse. I have a timer. That timer is going to be used in conjunction with the encoder, um, and we're going to set a time limit on it, and then once it reaches that time, it'll stop doing its maneuver. Um, Constant integers, encoder left and encoder right. That is for the encoder itself. I'm only using the left one, the right one burned out, but it works just fine, and you will see that in a minute. We use the serial bus, or we use the serial, not bus, serial bus. Okay, I'm an audio engineer, so a serial bus means something different to me. We use the serial monitor to start printing out things that are useful to us. For instance, the distance and the timer, the count versus the timer, because every time the encoder runs, it acts as an interrupt, and every time it's interrupted, it counts ahead one, basically. So, and here's the attached interrupt right here. We're using the left encoder. Update encoder basically just all it does is increments it by one, so it just keeps adding to it on the rising side. So what that basically means is that as it is going from low to high, it is going to snap and it's going to increment one. Okay, so main loop, we're basically sending a signal from the trigger of the distance sensor. We're setting a high to low, okay, in 1 second increments, in microseconds. I'm sorry, we're doing it in microseconds, so it's definitely not a second. It is basically a millisecond. Okay, and then we're taking that duration, okay, and we're using the echo, pulsing in the echo, and we're taking that duration, dividing it by 2, and then dividing that by 28.5, and we get our distance, which is going to be in centimeters. So if the distance is less than or equal to 7 centimeters, which is pretty close right now, but for demonstration purposes, it works just fine, it's going to go into emergency stop mode. We're going to stop the robot. It is going to continue to stop until it is out of harm's way. So if the distance is less than 14 centimeters and the distance is greater than 7 centimeters, it is going to say that there is an obstacle detected, and it's going to initialize a maneuver. That maneuver is it is going to stop the robot. It is going to wait for 1 second. It is going to go in reverse for a certain amount of time, depending on the interrupt versus the timer. Once the interrupt reaches the timer state, it is going to jump out of that and then start turning left. And then the turn left uses the interrupt to determine how long we're going to turn. And then it's going to wait, and then it is either going to go move forward, stop, or it is going to turn again. So as long as the distance is greater than 14 centimeters, it is going to move forward. Okay, now I know this is on the short side of things, but for demonstration purposes, it works really, really good. If the car is going to be mobile on the floor and stuff like that later on, I'm going to change those distances to reflect something a little bit more realistic. But for now, it works great. So the code is basically, the functions are simple. I got a forward direction. We set the timing to 100. We say we're going forward. While the counter is less than timer, it's going to go forward. I use a short timer because I want to check this more often. And so basically, it's going to recheck this right now with the way the interrupts are and stuff like that. Centimeters, distance. We're going to probably run this at around every 1.5 to 2 seconds. It's going to check. Okay. So reverse, it's the same thing. Obviously we're going to have to write the pins. I use an analog write for the encode pins that are going to basically control the speed of the motor. Okay, and what that is going to do is it's going to send an analog signal from 0 to 255. 255 is high, always on. 0 is low, always off. Anything in between there is going to be basically handled as, well, for us, it's going to be handled as a percentage. So half of 255, the motor is going to be running at half speed, and vice versa. To be honest with you, I don't use it that much because of the power settings on here. I'm only running off the 5-volt rail on the Adreno. These motors actually are going to be best between 9 and 12 volts. But just for simple purposes, I use 5 volts. It works fine for now. Obviously, when I wire this up and solder it together, I'm going to use a 9-volt battery as the optional power source for the motors. But for now, no, I'm good. Okay, so here's the thing. So digital write, these are your pins. A and B control the left motor. You got a left motor, a right motor. You got A and B pins. High and low, basically, that's the signal for going forward. We look here, low and high is reverse. It is going to go in reverse. Left, high, low, low, high. Okay, so that is going to turn left. One motor is going to spin one way, the other is going to spin the other way. And we reverse that for right. And then we have a stop robot. Basically, we put the 2 analog writes into 0, and I delay a second and check every second whether or not that distance is still the same or if we're in the clear. Update encoder. Encoder basically increments the counter by 1, and how we control that is we use a timer. For this is 50, while counter is less than timer. We're going to perform the program. That's turn right. If the counter equals timer, then we set the counter back to 0 and jump out of the program. I really didn't need any more than this, to be honest with you, for turning. it actually works pretty good. So without further ado, I'm going to demonstrate this on the serial monitor. And then after that, I'm going to demonstrate it real world application. Okay, so here we go. So we are going to start the serial monitor. All clear, moving forward. Okay, it's giving you a distance. It is giving you interrupt. It is showing you interrupt. Obviously, it's going a little bit past the 100 mark that I have, but that's okay. It resets itself. It's going to keep doing that, moving forward until something happens. So let's see what happens when it starts to encounter an object. Okay, moving forward. Object detected, initializing maneuver. It stops, it goes backwards. Then it turns left. Once it turns left, it goes forward, and it'll keep going forward until something else is detected. So, object is detected, stop, go backward, turning left. Object is detected still, stop, go backward, turning left. All clear, moving forward. Working great, right? Until, something happens and we need to apply the brakes like right now. Boom, emergency stop. Now it's going to back up, emergency stop, emergency stop. It is going to remain in emergency stop until we get past 7. We're going to move out. Obstacle detected, initialize maneuver. Going to go backwards, turn left, get out of the way. Okay. Now it's moving forward, right? It hits a wall. Boom, emergency stop. It's going to remain there until we move it. Let's move the car someplace. All clear, moving forward. Going along, and it is approaching something. Obstacle detected. Go backwards. Turn. Move forward. And it's going to keep doing that until we either shut it off or an obstacle detected and an emergency stops. Right? Okay. Boom. Okay, that's it. Now you're going to see this in action. Thanks, guys. I had a wonderful time with this. This was so much fun. I love it. This is what robotics is all about. And I will see you in a minute. Thank you. Hey, guys. Okay, so this is the final part here. I got the robot assembled. It's not soldered, so it's a little on the flimsy side right now, but it does work. I'm not going to actually put it on the floor and do it because it'll fall apart. So, and besides, the power mechanism is not hooked up actually. So I'm going to use this and plug it into the Arduino for power, and I will simulate it running across the floor, running into an obstacle. So without further ado, let's put this together. Hold on one second. Pardon my sloppiness here. All right, let's get her working. Okay, so she's going forward. Hold on. Oh, it stopped. Hold on. Let's get it going forward again. Come on, go forward. All right, so it's going forward, right? Going along. Okay. So then it backs up, turns. See it turning? Goes forward. Now it's going forward again. Now that's because it initiated the turn. Now let's do an emergency stop. Okay, there's the emergency stop. It is going to remain stopped until you get it out of the way. Now I got to tweak the distances here a little bit, but all of the program is running. So let's back it off a little bit. Okay, now it senses that it's, so what it did is it went in the reverse and then turn mode. And then now it's going to go back to driving until it reaches another part. Backs up now. See, it's backing up, turning, and it is now engaging back in the forward drive. Again, emergency stop works. Okay, the distance works here. It is going to back up. Now it is backing up, turning, and it is now going forward. Let's go back. Senses it, backs up, turns. Now it is moving forward. Okay. Emergency stop. Okay, so we demonstrated it. Everything is working great. I wish I could do a better demonstration, but this will work. I mean, everything is working great. See? Works just fine. Backing up. Oh, for some reason, every once in a while I won't get the motors will kind of act funny. There we go. Need a little extra push. I think it's because I'm running on a low power setting. So, all right, forward, 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 forward. Senses it. Back up. Turn. Turning. Going forward. Yes. Okay, that is the end of my presentation. Thank you very much. Have a great day.